Hello and good day. We are Group 4E presenting for Zero Waste in Wastewater Treatment Industry. Before we start our presentation, I would like to introduce myself. I'm Belinda Wong and our members are Aini Sophia, Lim Sharon, Navinjit Kaur, Phua Hui Singh and Tan Yong Cheng. First and foremost, wastewater treatment process plays a vital role in the continuous production of good quality of water. There are 4 common ways to treat wastewater, which include physical, biological, chemical, and sludge treatment. One of the physical water treatment methods, reverse osmosis, is a pressure-driven membrane process control system discovered to be widely used for the treatment of municipal or industrial wastewater. Reverse osmosis process is normally used in several applications such as selective separation, purification of water, and concentration process in food and beverage industries. With the pressure applied, the reverse osmosis separates the dissolved solids from the water through a semi-permeable membrane via solution diffusion mechanism. As the reverse osmosis membrane is hydrophilic and semi-permeable, the water will be able to diffuse in and out of the polymer structural membrane, and mostly the suspended solid or large molecules are managed to be separate from the water stream. Despite the potential and advantages of using a membrane-based water treatment process, there are still a lot more limitations or challenges to be considered. This includes the low permeation flux, less selectivity, less membrane durability, and membrane volume. Thus, process control system being an important role to maintain a quality process operation of many industries. With the problem statement, we have the objective of, first, to study the type of control system involved in the reverse osmosis process. Second, to justify the implementation of the control system with environmental and chemical engineering elements. Third, to identify the challenge faced in using process control system in the chemical industry and recommendation to address the challenge.
Hi, I'm Navinjit Kaur out of Uttam Singh, and today I'll be doing the methodology part. Reverse osmosis is one of the most popular separation technique used mainly for the purification of water. Reverse osmosis, a pressure-driven membrane process, is one of the physical water treatment methods where it is discovered to be widely used for the treatment of municipal or industrial wastewater due to the involvement of low cost. It involves a diffusive mechanism so that separation efficiency is dependent on solute concentration, pressure, and water flux rate. The efficiency of a reverse osmosis water filter is affected by the water pressure coming into the system and the temperature of that water. Reverse osmosis involves 4 stages, where the first is sediment filter, followed by pre-carbon block, next reverse osmosis membrane, and lastly post-carbon filter. The advanced membrane material, process design, and energy recovery have resulted in low-cost production of the semi-permeable membrane to be used in the reverse osmosis process. The figures in the slide shows the process flow diagram of a reverse osmosis control system. The unprocessed water is pushed through a wire strainer in the unit to get rid of any big particulates. After that, the water flows through a cartridge filtering stage with a 5 to 20 micron filter. To remove any residual hydrocarbons that have been dissolved or emulsified, the water is traveled through an organoclay adsorbent vessel at a pace that allows for a 5-minute or longer residence period to accomplish that requisite oil removal. Microfiltration or ultrafiltration as an intermediate pre-treatment step is considered. The de-oiled water is then sent via a high-pressure positive displacement pump to boost the pressure to 600 to 1200 psi, which is the working pressure for reverse osmosis. In the high-pressure tank, a PID controller is used to maintain pressure at a given point. The reverse osmosis membrane separates the flow into concentrate and permeate streams. The concentrate is the largest stream, accounting for approximately 85% of the total flow of the operation, and it may be regenerated back to the feed water. The concentrate is regenerated until the salt concentration in the feed water exceeds an upper working limit, at which point the permeate or fresh water departs the process. The diagram shows the simulation concept of robust PID controller. In this experiment, a robust PID controller structure is used which is composed with new type of integral control action. The conventional PID controller is limited because of its poor performance due to actuator saturation and nonlinear effects. In order to resolve these problems, a novel control scheme is proposed by integrating improved integral control and nonlinear gain. The improved integral control has concept of error window and weight function concept. Also, nonlinear gain has squared deviation action. The performance of newly proposed PID technique is compared with those of conventional ones via simulation.
Present the justification of the proposed process control system.
Now I'm going to present the type of the controller. For PID controller, it is continuously calculate the error value as a difference between a desired set point and a measurable process variable, and apply a correlation based on the proportional, integral, and derivative term. But for the conventional integral, the controller integral section is between 0 until present. But for the new type of integral controller, the integral section is between specific past time and present time. Robust control is a control design method that focuses on the reliability of the control algorithm. Robustness is usually defined as a minimum requirement of a control system have satisfied in order to be successful in a practical environment. Now I'm going to present the justification based on the simulation result. As you can see in the graph, the settling time of the robust PID controller is shorter compared to the conventional PID controller. The settling time is the time required for an output to reach and remain stable in a given error band, followed by some input stimulus. Therefore, as the shorter the settling time means that it's more easier and efficient for the controller to set the outcome to a set point. Well, for the overshot, we can see that the robust PID controller has a lower overshot value compared to the PID value. Overshot value is a value to show how much the system exceeds the targeted value, which is our set point. Therefore, the lower the overshot, we're able to minimize the response times and make the system more efficiently.
Now come to the integral of time multiplied by absolute error of robust PID versus conventional PID controller. According to the graph, initially you can see that the robust PID and conventional PID is at the same value, but conventional PID started to increase dramatically after 7 seconds. However, robust PID become a straight line. Therefore, we can say that the stabilizing time and peak time for robust PID is shorter than conventional PID controller. Next is the response of robust PID controller versus the conventional PID controller under the load disturbance. Based on the graph, we can clearly see that the stabilizing time is more shorter for robust PID compared to the conventional PID controller. However, for the overshoot, it is more lower than the maximum error obtained through the conventional PID compared to the robust PID. Continue with the integral of time multiplied by absolute error of robust PID versus conventional PID controller under the load disturbance at 45 seconds. The graph shows that the stabilizing time for robust PID is more shorter than conventional PID controller. The peak time for robust PID is also shorter than conventional PID. As a result, robust PID controller is more suitable compared to the conventional PID because the response error of robust PID is decreased along with the time and the error is not accumulated, which stabilizes the system. Then the response error of robust PID is decreased drastically, which will also make the system become more stable. The new concept of robust PID is successfully implemented and proved to be very effective compared to the conventional PID.
The challenges in treating wastewater are varied and depend not only on laws governing effluent control but also on regional characteristics and socio-economic conditions. The major challenge in wastewater treatment plant is sludge production. Asian region contains higher contaminants in raw wastewater compared to the European and North American countries in study report. The higher levels of emerging contaminants also growing concern for sludge management. It is because sludge may contain harmful components such as pathogenic organisms, organic compounds, heavy metals, and excess phosphorus and nitrogen. It may lead to disease and health risks to humans. Second challenges are to implement a cost-effective and high-performance wastewater treatment system. It is because the larger operational cost, it will lead to the emission of greenhouse gases. Anaerobic digestion is important in transformation into biogas. However, a scale of an anaerobic digestion is not sufficiently large to be able to capitalize on merit of scale. In addition, capital and maintenance costs also high. Moreover, to do anaerobic digestion is difficult too.
Hi, good day everyone. I'm Tan Yong Chen and my student ID is 190000488. Today I'll be talking about recommendations. The recommendations are strategies to reduce sewage sludge and strategies to decrease costs and lead to high performance. The strategies to minimize sewage sludge are adopting a waterline procedure that decreases the generation of sludge and carrying out dewatering procedures by lowering the water content. Besides that, reducing the percentage of volatile solids is also one of the methods to reduce sewage sludge. Next, I'll be talking about the strategies to decrease costs and lead to high performance. Reverse osmosis is membrane-based water treatment process and membrane folding will occur. Thus, in order to reduce the effect of the membrane folding towards the entire wastewater treatment process, scheduled cleaning of membrane should be carried out. Besides that, the ultrafiltration pretreatment should be carried out as it is used to pre-treat high-falling water sources such as wastewater. This is because ultrafiltration pretreatment is continuous without a breakthrough in granular media filtration, and the reverse osmosis membranes are protected without the use of additional chemicals. As a result, the membrane can operate effectively for a longer time with little folding and high performance. Energy consumption decreases and will cause the operational cost to decrease. That's all from me. Thank you for listening.
In conclusion, our group has successfully discussed about zero waste in wastewater treatment industry. We can conclude that the proposed new robust PID controller is successfully implemented and proved to be very effective one. Furthermore, the decision methodology of the setting parameter and the stability analysis in the frequency domain are underway for the new controller. Lastly, strategies to overcome challenge in implementation the proposed control system in the industry, which are sludge production and cost-effective and high performance, are recommended. That's all for our presentation. Further reference can be referred to the next two slides. Thank you.